Hello to all my viewers. This is Dr. Dhaval Mehta, and today we are going to discuss Retrieval Augmented Generation Prompting Techniques in Large Language Models. Retrieval Augmented Generation is a natural language processing technique that combines elements of both retrieved-based and generation-based approaches. In RAG prompting, the model is provided with a prompt or query, and it uses retrieval mechanism to gather relevant information from a large knowledge base or corpus. It then generates a response based on the retrieved information, incorporating additional generation capabilities to produce coherent and contextually relevant outputs. So let's try to understand RAG modeling by this figure. When any prompting is being done, the model starts searching for specific relevant documents from the databases. Then the model augments the retrieved content by providing additional context and explanations for each query. Then this particular information is passed through LLM, that is a large language model. It starts acting as a generator, and then it generates the new text, which was not existing previously. What are the advantages of RAG? RAG prompting combines the strengths of both retrieval-based and generation-based method, allowing models to leverage pre-existing knowledge while generating contextually relevant responses. This results in more comprehensive and informative outputs that better capture the nuances of the input query or prompt. By retrieving information from a knowledge base or corpus, RAG prompting ensures that the generated responses are grounded in factual data and relevant context. This helps mitigate the risk of generating inaccurate or misleading information, particularly in domains where factual accuracy is crucial, such as healthcare or finance. RAG prompting leverages efficient retrieval mechanism to quickly search through large volumes of textual data and identifying relevant passages or documents. This scalability allows RAG models to handle a wide range of queries and accommodate diverse user needs without sacrificing performance or response times. RAG prompting is highly adaptable to different use cases and domains as it can be tailored to specific knowledge bases or corpora relevant to the text at hand. This flexibility allows organizations to customize RAG models to their unique requirements and address specific information needs or conversational intents. Compared to purely generation-based approaches, RAG prompting often requires less training data to achieve comparable performance. This is because RAG models can leverage existing knowledge from external sources, reducing the reliance on large-scale training dataset and potentially lowering the barrier to entry for model development and deployment. RAG prompting enables transparent and interpretable responses by explicitly referencing the retrieved information used to generate the output. This allows users to understand the rationale behind the model's decision and provides valuable insights into how the model arrived at its conclusions. RAG prompting can handle noisy or ambiguous input queries more effectively than pure generation-based models by leveraging the redundancy and diversity of information available in the knowledge base. This robustness helps ensure the RAG models can provide meaningful responses even in challenging or uncertain scenarios. Let's take the limitations of it. Implementing RAG models can be computationally intensive, particularly when dealing with large-scale knowledge bases or corpora. Retrieval and generation processes require significant computational resources, which can limit the scalability and efficiency of RAG systems, especially in real-time or latency-sensitive applications. The effectiveness of RAG model heavily depends on the quality and relevance of the underlying knowledge base or corpus. If the knowledge base is incomplete, outdated, or biased, it can negatively impact the retrieval and augmentation processes, leading to inaccurate or unreliable responses. RAG models may struggle with semantic drift and maintaining contextual understanding over longer conversations or sequence of prompt. As the conversation progresses, the model's ability to retain and accurately interpret previous context may degrade, resulting in less coherent or relevant responses over time. RAG models are trained on specific knowledge bases or corpora, which may limit their ability to generalize to unseen or out of domain queries. If a query falls outside the scope of the training data or requires knowledge beyond what is available in the knowledge base, the model may struggle to provide meaningful responses. RAG models are susceptible to inheriting biases present in the underlying data used for training, including biases in the knowledge base and training corpora. This can result in biased or unfair responses, perpetuating stereotypes or misinformation, particularly in sensitive or controversial topics. RAG models may lack interpretability and explainability, making it challenging to understand and interpret the reasoning behind the responses. This opacity can be problematic in critical applications where transparency and accountability are essential, such as healthcare or legal context. RAG models may pose risk to data privacy and security, especially if they have access to sensitive or confidential information stored in the knowledge base. Unauthorized access or misuse of the data could lead to privacy breaches or security vulnerabilities, raising ethical and legal concerns. RAG models are often designed and trained for specific domains or tasks, which may limit their adaptability to broader or cross-disciplinary contexts. Adapting RAG models to new domains or tasks may require significant training or fine-tuning, which can be time-consuming and resource-intensive. How RAG is working. The process starts with providing a prompt or a query to the RAG model. This prompt typically consists of natural language query or statement expressing the user's information, need, or conversational intent. For example, the prompt could be, what are the symptoms of COVID-19? Once the prompt is provided, the RAG model leverages retrieval mechanisms to search through a pre-existing knowledge base or corpus. This knowledge base contains a vast amount of structured or unstructured data, such as documents, articles, web pages relevant to the prompt. The model retrieves relevant information from the knowledge base based on the prompt. It may use various retrieval techniques such as keyword matching, semantic similarity, or document ranking to identify the most relevant documents or passages related to the query. After retrieving relevant information, the RAG model augments or enriches the retrieved content using the generation capabilities. This involves synthesizing the new text based on the retrieved information, incorporating additional context, explanations, or insights into to provide more comprehensive response to the prompt. Finally, the RAG model generates a response based on the augmented content, this one. This response is typically in the form of natural language text, presenting the synthesized information in a coherent and contextually relevant manner. This generated response is then presented to the user as the output of the RAG prompting process. Now let's see how we can do this. I will copy this prompt. What are the symptoms of COVID-19? So it has started retrieving the information. So this is the result of augmentation, and then the last one is generation of a new text from it. See, we had just asked what are the symptoms, and it gave me the symptoms, less common symptoms, severe symptoms. Let us regenerate. Still you can regenerate. If I add something more in it, any other information, so now it gives me the new text, which was not there previously. See. So this was all about retrieval augmented generation prompting. For more videos on prompt engineering, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.